In this video, we are going to be calculating slope from 2 points using the slope formula and something I call the slope table. And we are also going to be using the point slope formula to generate the slope-intercept form of a line from some given information, whether we have a slope and a point or a slope and a y-intercept, or a slope and a separate point, or just 2 points. So we're going to be doing all of that in this video. So I mentioned that we would be using the slope formula, or what I call a slope table. So this is a little method that I have that is essentially doing the exact same thing as the slope formula, but I find it to be a little bit more straightforward. So I've got my ordered pairs set up here in my table, and so now I just want to ask myself, how did I get from -1 to 4? Well, I added 5. And how did I get from -3 to -2? Well, I added 1. And I know that the slope is the ratio of the change in y to the change in x. So my slope on that problem is +5. On the next problem, I'm going to do the same thing. I'm going to set up my slope table, fill in my ordered pairs, determine the change in y, determine the change in x, and then I have a slope of 7 over -5, which gives me -7/5. So that one has a negative slope. We're going to use the slope table again. -2, -1, -2, 4. How did I get from -1 to 4? I went up 5. How did I get from -2 to -2? I added 0. And that is going to be something special, because with the slope being the ratio of the change in y to the change in x, we have to remember that we are not allowed to divide by 0. Wherever we divide by 0, that number is undefined. So for this equation, the slope is undefined, meaning that we have a vertical line whose equation is x equals -2. And the last one on this section, set up my slope table, 5, -1, -4, -1. The change in y is 0, and the change in x is -9, and the ratio of 0 to -9, 0 to -9 equals 0. So this one has a slope of 0, meaning that it is a horizontal line with the equation y equals -1. So we have that slope of 0 there. So that is calculating slope. Next, we want to use some given information and determine equations of lines. So up here on the graph, we want to identify the y-intercept. There it is. It's at -2. And then we want to count out the slope. So I'm going to zoom in here a little bit. And the rise is 4, and the run is 1. We always want to use lattice points to determine slope, because even though this point right here is a point on the graph, we'd have to estimate the x. Same thing with this one and this one. But if we go up one more, we can see that that crosses exactly at intersecting grid lines, which makes it a lattice point. And so that is what we want to make sure that we are doing when we are calculating slope from a graph. We always want to use a lattice point. So that change in y is 4 over that change in x of 1. That ratio of 4 over 1 gives us a slope of 4. And the y-intercept is -2 because the graph crosses the y-axis at -2. So to put that into slope-intercept form, all we need to do is just plug those numbers into the formula. So we have y equals 4x minus 2. So here was our slope, and here's our y-intercept. And then the point slope form of it, we're going to be using this formula up here. So we're going to have y minus y1 equals m times x minus x1. And anywhere you see a subscript, that is going to be a value that we're going to substitute into this formula. Okay, we're also going to substitute the slope that we calculate or find from the graph. So I'm going to use the point 1, 2, that other lattice point that we found on the graph. I'm going to use that one to substitute into my point slope formula. So I'm going to substitute 2 in place of y1 and 1 in place of x1. Now the variables that are still in the black ink are not going to change. Those are going to remain in the formula as y and x while we substitute numeric values into the other ones. So I substitute my y value, my slope, and my x value, and now I need to distribute that slope and add 2 to both sides in order to isolate y. So we get y equals 4x minus 2. So we did get the exact same slope-intercept form from this point slope form. So I can just write that point slope form on my line right here. So I'm going to have y minus 2 equals 4 times x minus 1. In example 3, we want to find the equation of a line in slope-intercept form that has a slope of -7/9 and a y-intercept of 16. So this one gives us the slope and the y-intercept, so we actually don't have to do any math at all except for substitution. So we just want to take that slope of -7/9 and substitute it into the slope-intercept form in place of m. And we will substitute positive 16 in place of b, and that is all there is to that. Example 4 asks us to find the equation of a line in slope-intercept form that has a slope of -2/3 and contains the point -3, 6. Since we are given a point and a slope, we want to use the point slope formula. So I'm going to have y minus y1 equals m times x minus x1. Since this is a negative number, when I subtract a negative, that's the same as adding. So I've got my negative from the formula right here already. Instead of writing a -3 out to the side, I'm going to cross that negative through and put the 3 out there like that. Because subtracting a negative is the same thing as adding a positive. Now I need to distribute that slope . So I'm going to get that done. We have -2/3 x minus 2, because -2/3 times +3 gives us -2. And then I still have my y minus 6 over on the left, and I want to add 6 to both sides to isolate y and convert this to slope-intercept form. So I have y equals -2/3 x plus 4. That is my slope-intercept form of the line that has a slope of -2/3 and contains the point -3, 6. The last example on these notes gives us 2 ordered pairs, and we want to find the equation of the line that passes through those. So I need to find the slope first. Then I'll choose a point and use the point-slope formula to find the slope-intercept form of the line. So I've got my points 2, 3, and 5, 9, and the change in y is positive 6, and the change in x is positive 3, and our slope is the ratio of the change in y to the change in x, and we simplify 6 over 3 to 2. So our slope is 2, and now we just want to choose one of the points that we were given and substitute the slope and a point into the point-slope formula. So I'm going to choose this first point right here, simply because it's got smaller numbers. So I'm going to substitute 2 in place of x1 and 3 in place of y1. So y minus y1 equals m times x minus x1. So we said we're going to substitute 3 in place of y1. We found the slope to be positive 2. And we're going to substitute 2 in place of x1. Remember that there are minus signs in the formula. So when we substitute positive values into that formula, the minuses are going to be there still. So now I'm going to distribute that 2. So I have y equals 3 on the left, and then distribute the 2 to both terms, giving me 2x minus 4. And then I can add 3 to both sides of the equation, which will give me the slope-intercept form of y equals 2x minus 1. And that is it. We have calculated slope from 2 points, and we have used several different types of information to find slope-intercept form of a line, whether we are given the slope and the y-intercept, or whether we're given a point and a slope, and we use the point-slope formula to convert to slope-intercept form, or whether we're given 2 points and asked to find the slope and generate the slope-intercept form of the equation.